Okay, I'm going to go over some of the questions that you guys had from class. I had a lot of people asking questions about the fractions in this very last question, and then I had a few people asking about g of x up here also. It's very difficult for me to create an accurate graph on this video, and so I'm mainly going to focus on what the points are that you should be graphing, and then you can just make sure and plot them on your grid. And then one more thing, you can just ignore these little boxes. Those are just typos on this electronic version. So first, if I take a look at h of x down here in the bottom, my very first part of the function is going to appear between -7 and -2. So I'm going to draw my dashed lines here to guide my thinking. I know that the first part of this graph is going to appear in between those two lines right in here. If I use a table of values, this is where it gets a little bit tricky because I'm going to wind up with fractions. I'm going to think about plugging in -7 and -2 because that's where my two endpoints lie. And I'm going to use order of operations. So moving down here, I've got 2/3 times -7 plus 3 plus 2. If I'm evaluating the parentheses first, -7 plus 3 is -4. So I really have 2/3 times -4 plus 2. 2/3 times -4 is -8/3. And then I can use a fancy one of 3/3 to multiply times the 2 to make that into a fraction with a 3 in the denominator. So I'm going to add 2 times 3 is 6. The 3 stays the same. So -8/3 plus 6/3 is going to be -2/3. So that's going to be my y value here. So I could plot the point -7, -2/3 on my grid. -2/3 is going to be below 0, but not below -1. So I'm thinking about that little point right there. If I kind of start over with this and think about -2, I've got 2/3 times -2 plus 3 plus 2. Evaluating the parentheses first, -2 plus 3 is just +1, so that's really just going to be 2/3 plus 2. We already did the fancy one of 3/3 with the 2, and we know that that is 6/3. So when I add those two up, I get 8/3. And if I think about this, 6/3 is equal to 2. And 9/3 is equal to 3. So 8/3 has to be in between 2 and 3, and it's going to be closer to 3 than it is to 2. So I'm going to pick up my blue dot again, and I'm going to go to the point -2, and then 2.666. So that's going to be right up here. This one's going to be a closed dot. And then I can connect my line here. Let me erase. So any 2 points make a line. That's enough for me to have that part on the graph. And now I'm going to work down here on this part. Let me get a different color. This one's going to fall in between -2 and +5. 1, 2, 3, 4, 5. I think this is 5. And when I look at this, I can see right away one point, a locator point, because there's nothing out here. This is really -4/3 times x minus 6 plus 0, we can be thinking. So I know that I have a point on the grid that is 6, 0. That would be helpful, except that that's outside of where my domain ends. So I can't actually put that point on the graph unless I erase it when I'm through. If you want to erase it when you're through, you can plot that point. So I can go to 1, 2, 3, 4, 5, 6. put that point on the graph right here, and then use the slope to count the rest of the points. And in this case, we talked about this a little bit the last couple of days, but in this case our slope is negative, so I know that I'm going to wind up with something that looks like this when I'm done. But I'm used to traveling to the right, so if I need a negative slope and I'm moving left, I'm going to put the negative in the bottom. So what I'm really saying is I'm going to count up 4 and over 3 to the left. So from there I go 1, 2, 3, 4, over 1, 2, 3, and I'm going to put a point here. Up 1, 2, 3, 4, over 3. Up 1, 2, 3, 4, over 3. This one's got to be an open dot. That gives me enough to connect everything except when I hit this line. I'm going to make that also an open dot, and then I'm going to make sure and go back and get my eraser, and I'm going to come over here. I'm accidentally erasing the part that I don't want to. It's not letting me erase that part. So I've got my open dot here, and then I'm going to get a different color and show you what I would erase. I would erase this part right down here. Just erase that so it's not outside of the domain. And that's all there is to that one. Okay, hopefully I can focus now on g of x. G of x, I see the boundary line is going to be at +2, so I'm going to think about my dashed line here. I know that the top function rule corresponds to all the values where x is greater than or equal to 2, so I'm talking about this part over here. And when I look at this, I know it has a positive slope, so I've got something that's going to look like this on this side of the line. I'm going to take and I'm going to substitute in values, so if I'm thinking about my xy chart, I might think of the point 2, 3, and 4. I'm picking 3 and 4 because they fit the domain restriction. They're bigger than 2. 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. So I can plot these points. This is going to be a solid dot. Got the point 3, 2. Got the point 4, 3. And from there, it's going to go on forever. Put an arrow on the end. When I go to do the second part of the domain, now I'm looking at the left-hand side of the graph. Because I'm looking at the left-hand side of the graph, I'm going to think about where my point's going to be on where x is 2. But I'm also going to choose values that are smaller than 2. So I've got 5 minus 1/2 times 2. 1/2 of 2 is 1. So that's 5 minus 1, which is just 4. I can think about 1, but I know that if I substitute 1, 1 is not divisible by 2. Since 1 is not divisible by 2, I'm going to be forced to deal with the fraction if I choose 1. Because you get to choose your own values for this table, we can just mark that off if we want and deal just with the numbers that are easy to do. If I substitute in 0, 5 minus 1/2 times 0 is just 5. This gives me 2 points, which is all I need to determine the line. So I'm going to put an open dot this time on the point 2, 4. And I'm going to put a point at 0, 5. I'm going to connect them, and hopefully you're using a straight edge, which I don't have on this thing. And I'm going to put my arrows at the end. And that's all there is to it.